Hello, my name is Nagisep Coach, and today my topic is about representation of the block diagram. Representation of digital time signals in block diagram. There are different types of representations. Let us take a recursive realization of the block diagram representation. In the recursive realization of the block diagram representation, we know that in recursive type, we know that the function y of n depends upon the past outputs, past and present inputs. This form corresponds to an infinite impulses and the response digital filter. And for the non-recursive realization, the current output y of n is a function of past inputs and the present outputs. We know this from the equations. And let us prove it how we know from that equations. And this, let us say this is a small IIR filter or infinite impulse signal. Now let us take Z transform for that signal, and we can see that by applying Z transform to the signal, we can see the present input which depends on the past input and the present output, which says that the system is a recursive system. So we can realize any type of system. In the recursive realization. This, now let us take a transfer function of the recursion realization. The transfer function is the output function to the input function. Now this is the transfer function. Generally, the transfer function says that transfer function for the recursive filter is typically leads to an infinite impulse signal. The behavior, if the denominator is equal to unity, that is no feedback is applied to the signal, then it forms FIR filter. That is the two different filters which we will use, which are IIR filter and the FIR filter. The IIR filter usually have the feedback, and FIR filter does not have any feedback. This is the general system function. Of the equation, and we can see the corresponding equations of the system. Now let us assume if you want to draw the signals, the impulse system into a block diagram, which we can assess by using three different elements, which are adder, multiplier and unit delay. The adder adds the output and the input, and the multiplier just multiplies the signal, and the unit step delay is the most important part, which adds some delay or Z transform or some amount of transform to the signal. Now let us see, this is the example. Let us take a small example and see how the output will be. Now y of n equal to a of y of n. We can see if you want output as a y of n, then we have to add the inputs of this signal to the x of n through this equation. That is what we have proved here. So there are different types of drawing the IIR filters, the IIR systems, which are direct form, two structure, cascaded form structure, parallel form structure, and the transported form or lattice form and ladder form structure. In different structures, these we have to know what is the basic form of the IIR filter. The basic form of the IIR filter includes all of the zero terms and all of the pole systems, and the output. The direct form. Now let us see the direct form. The direct form equation generally is taken like this. In direct form, this is the general block diagram of the direct form, where it requires m plus n plus 1 multiplication and m plus n additions and m plus n memory locations. This is the direct form method. This is the direct form method, where all of the zero system, all of the zero pulses, all of the zero system is applied at one side, and all of the whole system is applied at the other side. And in the direct form, there will be two n delay elements, and the limitations for the direct form is the number of delay system increases. The number of the delay system increases. It is not effective anymore. It lacks hardware flexibility, and it can be chances of instability due to the quantization bias. This is some example of the direct form. We can see we have taken the set transform, and we know these are the poles, and we know these are the poles, and these are the holes. Then we can say these are the poles. Second direct part, the direct form. The second direct form is the reverse order of the direct form 1. The second direct form, usually the general equation is in this form, where in the direct form 2, which requires m plus n multiplications and m plus n additions and m plus n memory locations. The direct form 2 has this form, where the n is maximum additions and m plus n, it requires m plus n maximum elements. Next is the cascading form. In the cascading form, it is nothing but this series interconnection of the system. Series interconnection of the system. It is used to detect the combination of both the signals. Both of the signals. And thank you.